Hey, everybody, and welcome back to the Kodiak Shack podcast. Today we have Dijam from Grid Raster, which is working on some AR, VR technology with ospreys, some robotics, some Space Force stuff. So really cool stuff that we've got them here. We've got Bender also helping ask those hard-hitting questions that we always do, not knowing really anything about VR, AR, or XR. So Dijam, thank you very much for being here today, and go ahead and tell us about yourself.
Well, thank you, Vader and Bender, to have me here. Really appreciate the opportunity here. Yeah, no, I'm one of the co-founders of Grid Raster. Currently take care of all the business development, product marketing, and partnership for the company. And at Grid Raster, we are powering in the cloud-based augmented reality and virtual reality. Most of the people are used to seeing those headsets where everything kind of runs. We believe that that's not how things will go really mainstream or scale up. So we are bringing in the cloud to act as a co-processor to those devices and power those, high performance, high precision, scalable, and, configurable experiences, which otherwise is not possible. So we have been working with a lot of aerospace, defense, and automotive and telecom companies on the commercial side, and beginning to find our footholds within the DoD, helping some of the customers within, like Warner Robins and CV22 program office, with some of the challenges they have. So I'm looking forward to the conversation.
Nice. Well, and it immediately makes me think of, if you're running a VR headset and you're trying to get high fidelity, high quality stuff, you're limited by what's housed on that VR headset. Where if you're running it on the cloud, you can have a lot more power behind your computing and processing. I assume that's the case, which is why you're doing that.
No, absolutely. That's the beginning of everything. What is there? The thing is, everybody's kind of starts about VR. It's all on the visualization part of it. Like, and visualization so happens is the fundamental part that you're trying to do. But there's a lot of scope that comes in terms of how do you take this new medium where you are capturing all this data for the first time and utilize other capabilities that is available, like the AI, and all those capabilities, bring together different sensors to make certain things more contextual and more situational. All those things is only feasible if you're kind of leaning on, the cloud, which provides you almost like infinite computing resources to do things what you want, and scale this across time and space. You're no more bounded by, you have to do there, right? So there's a lot of additional benefit that comes with, the cloud. But in the larger picture, what you're actually seeing, there's a good convergence that is happening of the different technologies, right? With AR and VR, AI, cloud, and then also a lot of sensor evolution that is happening. So we are taking advantage of some of that to make whatever we are making possible.
Yeah, nice. So so what you can kind of find online, and what I was looking at was your Osprey contract, right, with the Cyber 2 through AFWorks, and so
That's
now
correct.
you're working on the maintenance side, right? The maintainers AR possibilities.
Yeah, absolutely. So from a company perspective, in terms of the use case, since we bring in the infrastructure component, right, bringing in the cloud and other aspects. So we are applying that into multiple use cases. The Osprey happens to be where we are doing the repair and maintenance aspects. One of the repair and maintenance aspect around the nacelle wiring harness, which is one of the biggest performance degrader when it comes to the whole maintenance work. But we do also work across the product life cycle, like on the manufacturing with some of the top 2 primes, and we also work on the training with our cloud environment. We are able to bring that high fidelity simulations and training with multiple users across different locations playing that role. But yeah,
Nice.
but with the phase 2 that we have with AFSOC and the CV22 program office today through AFWorks, we are kind of bringing our capability to do high precision alignment of the wiring harness, the virtual wiring harness, and provide spatial instructions to the maintainer to be able to do the task faster and better, and almost kind of remove error in the process. So yeah.
Well, and yeah, now, I mean, I assume their TOs or tech orders are similar to like the F-16 ones. Another aircraft are, it's a PDF on a tablet that they kind of scroll through and they're like, okay,
You're
step
right.
one, step two. And
Yeah.
now taking that to the VR or AR space in this case, and it's got to just be so much more tangible, you know, especially for like someone who's spatially minded and they can see it on the machine. How do you get the fidelity? Because a lot of the times they talk about like laser mapping of the entire thing. Is that how you're kind of doing it? Laser mapping kind of each section of the engine as you break it down?
Yes. So what we have done for this project, we have used the LiDAR scanner to scan the whole, the area of interest. We didn't really scan the entire aircraft. It's not needed, but the wiring harness, the section that we needed to perform this, we did kind of use the LiDAR cameras to kind of capture it and create a corresponding model, high fidelity model of that. The interesting thing with this project that we are doing was the scanning that we did is essentially, this is for the machine, the AI algorithms to be able to detect where is the wiring harness, where are the clamps, all that to be detected, and not necessarily it requires a different fidelity than what a human vision will require. Like maybe if it is a training environment, that's a separate story, but we did scan using the LiDAR, but not necessarily we created a fidelity that is required from a human vision point of view. It was more around, the machine guiding you through those steps. So that is where we kind of utilize it for this project. Yeah.
Yeah, well, so it's funny because right now I'm going through a transition course for the F-15C, and you get a lot of academics. I think I'm here for about 3 or 4 months, and I get like 200 and some hours of just academics sitting in a classroom. And you go over the systems, much like maintenance working on these motors, and just so everybody kind of sees what I am seeing. So I'm in an auditorium type room with a projector, and I see the hydraulic system or the fuel system, and it's a 2-dimensional picture of this very 3-dimensional system. And I just imagine now, having kind of looked at the innovation space, like Bender, think back to when we were going through these academics, and if instead of looking at a PowerPoint of the systems, I'm walking around a real or a AR or a VR jet and seeing the system where it physically is in the airplane and seeing how they actually move, like that understanding, taking it from a 2-dimensional presentation to a 3-dimensional interactive experience, like talk about really understanding how these systems work and work together. I was like, dang, people need to make a AR or VR version of these systems academics, because it would change the way the end user, the operator, the pilot side really understands when they have an emergency and something breaks. Where is it? What does it look like? How is it actually affecting the airplane? So I appreciate that you're doing these things and you're giving that kind of fidelity, because I think there's a ton of use cases for them. So thank you for that.
No, it's happening. It's absolutely work in progress, and we are glad to kind of see that. Like even within the Air Force, I mean, the whole momentum has picked up so greatly, and to the large extent, it's happening because the initial results have been just absolutely mind blowing, right? The idea here is, the idea here is almost you're taking a physical hardware asset and creating a digital copy of it and just saying that I want to do whatever I want to play around and learn, at my own pace, because everybody learns differently, right? So that flexibility, that ability that you can simulate things, not only from a manufacturing alone, but from an operation angle, from a sustainment angle, and all of that you can do without risking any asset, without risking any personal, that's humongous. And it's already proven, right? It's like 85% more effective in terms of retention compared to any video-based training. So here, that's it. It's a case in those data points are just completely mind-boggling.
Yeah. When you think, I mean, Bender and I, and I think every profession has the requirement to be exposed to information and store it as fast as they can. And now we have technology that allows us to understand and process this information faster. So it's only going to make the future better. And it sounds like AR, VR, XR, all of them are just kind of exponentially getting better and better as the years go on.
Yep.
And so that's great.
That's actually huge. Not just entire. If you look at the entire industrial landscape, you are seeing that. Like if you, I don't know if you saw the recent announcement, maybe 6 months back or something, when Boeing announced the next design of their plane is going to be happening in the metaverse, right? Which is nothing but, that's convergence I was talking about of AR, VR, cloud, and, AI and all that put together. So, and more companies are kind of taking that path, and not at all, at least for us, it's not at all surprising, because we have been sold on this for the last 7 years and left everything to start this company. So,
yeah. Well, I'm glad you did. And Bender, back me up on this. So when I heard the robotics side, like the AR for robotics, it kind of blows my mind, because I struggle to like wrap my mind around exactly how that works.
I can't make that, at least not that visual connection in my mind.
So
explain that one a little bit.
Yeah. So no, just for the larger audience, like we kind of recently won a award from Advanced Robotics for Manufacturing Institute, which is basically funded by AFRL. It's all about using AR to improve the maintainability and the repairability of the assets, particularly in the manufacturing floor. So we all, as I was saying, like everybody talks about AR, VR from, human vision point of view, but a large part of that sustainment and manufacturing effort is more and more is to be done by the machines. And in this case, it's the robots. We are working with the Warner Robins Sustainment Depot, where they're basically using robots to kind of do paint masking, painting of the assets and repair, all the kind of repair that's kind of happening, right? So in this specific project, we are basically using, and today the way it is done is pretty manual. It takes a really lot of time. It's quite costly overall. And we are basically bringing in the over-the-counter headsets like Oculus Quest. Particularly in this case, we are doing the HoloLens. We're bringing in the HoloLens, and using the HoloLens, we are able to kind of scan a large structure and provide the corresponding coordinates in the 3D to the robotic arm, which is supposed to kind of perform that task. In this case, it's like painting of that larger dome, which needs to be performed by the robotic arm. We are able to use our capability using AR and VR and 3D AI, provide that 3D the 3D model of that with accurate coordinates, with the precision of into millimeters, which that coordinate system is now passed on to the robot, and the robotic arm then comes and performs the task which needs to be done, right? And this whole process, which has been manual, is being automated just by using this HoloLens. And we are expecting almost like we'll save the time. We'll do that in 1/8 of the time what's being done today. So that's huge. I mean, that's one of the examples. But the idea here is the overall system that we are building, while we are kind of using that as a representative use case to do that, but the overall system that we will build here is designed from an angle that it will allow any human to kind of interact with that whole digital data in a very seamless and intuitive way, and share this across time and space. You could be in different places, right? And you can do that in a different time. Like even you can kind of experience all that between all that interaction between the humans, the machine, and also the entire manufacturing process. So that's the piece that we are kind of doing right now, and it's going to be kind of more and more prevalent across any sustainment center, any manufacturing centers actually.
Oh, well, so I always wonder how the computer using the clear lens gets range? Is it using like a LiDAR, or is it literally just taking that kind of like photo optic assessment of, hey, this is farther away because of this, just the kind of physical reference?
And that's the beauty about the evolution of the technology or the headsets that's kind of coming in, right? The HoloLens today has both the RGB camera and the depth sensing camera. So you basically make use of those sensor data to kind of create and fuse those information, create the mesh of it, digital mesh of it, and create the corresponding model that is kind of required for the robotic arm to perform a certain task. So you no more have to have those custom dedicated scanners which would cost you maybe 20,000-30,000 K. You can do that with maybe 3,000 HoloLens, which will continue to reduce in cost, right? I mean, that's the beauty about using a commercially available technology, that the cost over time is going to reduce further and further, and then you are able to kind of scale that deployment as you see success with the initial deployments.
Yeah. I don't know. It seems, I was just talking with Bender and our buddy Rain on a different podcast about how there used to be those commercials of like, this isn't science fiction. This is like, reality. And now, like, again, over and over, we just see stuff where we're like, that doesn't seem like it should happen, but it just does. So what is kind of in the background, like how difficult of a lift is that for you guys to make that software, run that AI to actually produce these results? Like, is that a challenge, I would assume?
I mean, it has took us almost like 5 to 6 years of effort to where we are today, that we can make that seamlessly happen almost real time. Okay, so we take the burden there from our end users and make that available in real time to be done. And particularly for us, there are three primary layers of core IPs that is kind of involved in kind of doing that. First is our ability that we are able to create those high fidelity visualizations using the cloud infrastructure, because we can create the fine dense of the mesh that is required for this accuracy. Second is our 3D AI algorithms, which can kind of precisely track every object and identify all the objects that is there in the scene, and then simulate whatever the actions and the motions that needs to be kind of performed. And the third is take both those capabilities and make it scale in any system, like whether it's an on-prem structure or any public cloud environment or a private cloud environment or even a hybrid of those cloud environments. We can make that scale seamlessly. So yeah, so a lot of that infrastructure act has happened at the back of over the last 5 to 6 years of our effort.
So that brings up my question, if you don't mind, Vader. So how did you guys, like Vader and I assume most of the people, we would never think, in a million years, like, oh, this would be really cool if this was happening. Let's go find, maybe there's a company out there that like is kind of working on this. Let's reach out and contact them. So we wouldn't make that happen. So how did you get connected to especially with this, let's just specifically talk about the robot.
Like AFRO.
AI, like who reached out to you, or did you see that there was this requirement and you're like, hey, like we could do something awesome here? How did that process kind of go down?
Yeah, the interesting thing is, so for us as a background, right, like we have gone through this whole journey of, voice, video, and voice over IP, and we know that, the 3D world is going to be the next environment, right? The next computing platform is going to be AR, VR, and the convergence of the different technologies. For this specific case, we had the capability of kind of scanning, the large objects, right? And we can do that like instantaneously with very, very accurate, creating the accurate mesh. So we saw, a focus area which was put forward by AFWorks, where it was a large area scanning was one of the focus areas. And we reach out to the TPOC there, who happened to be Shane Groves, who has been like immense in terms of his innovation, direction, and vision. we reached out to him, and then we had an initial conversation, and he said that what we were saying is too good to be true. He needs to see it to believe it.
Yeah.
So we said, no, it makes sense, and we always believe this is something to be seen and believed. And so we really went down to Warner Robins, and then we demonstrated our capability, and we could do that without any, mostly with the AI models and all, you would need training of the algorithms. So we went there and we kind of demonstrated that with a large, structure there, and we could show that the accuracy, what we could bring in is almost like half an inch without any training of the AI algorithms, which was better than what was kind of already prevalent. And that basically kind of spurred all the conversations, and then we learned about this project, came in through the advanced robotics for manufacturing, and then we said, okay, this was a requirement which is coming to be happening there, so we kind of went after that proposal. And the good thing is, and which was the immense validation of what we are doing, was this opportunity was not a small business initiative. This was open to all industry. And since we had the core capability, and this is what we have been kind of building for the last 5-6 years, so we beat off the competition from some of the top primes, you know them pretty well, to kind of win this. So it was no small innovation research. It was an absolute cutthroat, competition based on, absolutely the data points that we have, the validation that we created. So, that's how we kind of got this opportunity, and now we are in the process of kind of making that happen. It's over 4 years. It's quite a big project,
Yeah.
but we'll go. We are gradually going to establish all of that.
Yeah, my guess is that the demand for what you're doing is gonna far outpace your ability to. Because even me, like, pretty limited, understanding the processes. Yeah, but I can think of like 3 things at my base. I'm at Hill Air Force Base, which has a huge maintenance depot for all the fighters. But I'm like, they would like knock down, walls to come find your stuff. And, you know what I mean? To like use it. So my guess is that you're just gonna get. I would think that in the DoD at least, that tons of people hearing about this would be interested in,
Absolutely.
applications of it.
Absolutely. We are already seeing some interest, because when we had the kickoff of the project, we had also people from like different agencies kind of join in, even other Air Force organizations join in. We are having some of those conversations, because some of the specific problems could be different for different, same capability, the 3DI capability, not necessarily from a robotic angle. It could be also utilized for other purpose. Like, for example, I can give you one of the discussion that we had with one of the Air Force agency was around holographic inspection of the defects, right? If you have the ability, like I'm sure, like when the maintenance happens, that there are a lot of spaces where not necessarily pretty, it's not an easy thing for a human to go in and, try to do certain things for a long time. If there is a way you can really scan that in a way that you can create it so accurate representation of it, and you have the corresponding CAD models available, and if you kind of diff that both with the accuracy that we have, which is like millimeters, you can pretty much kind of point out where the defects are. And then the human who ultimately will go and act on it just focuses on where the defects are, without spending time on scanning and all. So we are having pretty interesting conversations around different problems. And all these problems we will never learn like sitting here. It's only because of the end users and those conversations we are beginning to learn that and apply this technology to how to solve that. So there's pretty interesting conversations happening there.
When you think like, back in the old days when it's dirty jets and they're all like, it'll be fine with huge radar cross sections, and now we're talking about like super like refined ways of ensuring there's no impurities in these like surfaces of platforms, and you're like, I can see there's definitely like a very good use for this kind of technology. One of the things that always kind of baffles me is and people use it all the time, like, because you're in the industry, it's training AI. And as a person who's not like, doesn't work with AI, it's like, what do you mean training AI? So like, can you explain like how you train an AI to do these things?
Yes. So, I mean, as with humans, right? Like we see things, and the more and more we repeat, we get better at that, from a machine perspective. But the one thing we are good at, that if you have seen something, we just go, you put us back in that environment, we can quickly know what it is. And that's how the AIs kind of work a little differently there. They need more data points. You try to give them a lot of data points to get acquainted with the same thing, but it happens very fast. So, for example, like in case of the CV22 wiring harness that we are doing, in order for the AI to kind of know that, okay, here is the wiring harness of interest, it needs to first also understand the environment, because it has to find all the different points of interest, based on which, and those are the points that you need to train and let the AI know. Basically, you label it. You say, no, this is the harness. This is not an harness, right? So you go through that process, and the humans have to do that initially. The few things that, one of the core IPs for us has been there, like in case of like the Googles of the world who kind of go and, go in the road and collect like millions terabytes of data to kind of train something. In this kind of environment, you don't have that much data, right? So what we do is we do the scan of it, and then we use that scan to simulate to generate artificial data, which is again then used to train those algorithms, and then the algorithms are able to recognize, okay, here is the wiring harness, here is the clamp, here is what, and when next time you go and align it there, they will identify on their own. And the beauty about like the solution that we have, more and user uses our algorithm or our solution, it keeps on kind of learning. It's like it's a continuous learning. It happens. It gets more and more accurate at it. So every data that we take, we see it as an input to kind of process and improve the algorithm. And that's something which is like unique to, the machine learning part of it, right?
Yeah, hopefully it doesn't learn from humans, or it'll get some bad habits.
Now that's a different concern, right?
Yeah.
But yeah, till now, I think those concerns are quite far off. But there is a possibility, but they're really too far off, really, honestly.
Yeah. Well, and I think that's one of the things I talked about this in a previous episode, but I learned it a long time ago, where they said kind of, I got told by an instructor because I typed in the wrong thing in the airplane, and he said garbage in, garbage out. And I think that's the thing. Like if you give an AI good information, it's going to do really well. But if you give it bad info, then it may not do as well. But
it's the omelet is as good as the egg, right?
Yeah. I like that. Yeah. Well, and that's one of the things that it's, when I think of a computer, I think of something that I interact with, and it just does very scripted things. I put in an input to my laptop, and my laptop will give me a consistent output no matter what inputs I provide. But AI, it's learning, it's taking these things in, and it is making in the future different decisions based on the recent history or what it's experienced in the past. And I don't know. It's still, I understand that I don't understand, if that makes sense. Like it's beyond my brain.
So for us, one of the unique ways, we begin to kind of realize over the time is AI, like we say, like artificial intelligence, but more or less, like we see it as, it's something to amplify our intelligence with, things that there are some things they are good at, and we are good at some things. So decision making, for example, we can do in a flash of a second, but there are certain things they will take quite a bit of time to do that. But if those information is provided in a way that we are quick in decision, those things AI can really help do that. So it's like a amplification of our intelligence using AI. So
Oh, that's wild. That's so cool. So you said you guys are working on some Space Force stuff. So what are you doing with the Space Force?
Yeah, that's the area of interest like everybody has today, right? And it's not surprising that AR VR has a unique role to play there, and most particularly because space is an area where it's not like the humans or human operators are going to be there and going and flying in the space and fixing things up, right?
Yeah.
You pretty much are going to be reliant on the space assets like the the spacecrafts, autonomous. Most of them will be autonomous. But there are certain things that autonomous spacecraft cannot do, like, taking decisions in an uncertain environment. They do perform in very certain environments, right? So that's where most of what the activity you're going to see in the future, what happens in the space is going to be, it'll be autonomous spacecraft, but most likely with a human in the loop. Basically, human will be a supervisor taking some of the key decisions, and some of the aspects would be kind of done autonomously, right? So the work that we are doing as part of this, STTR, I mean, there's a lot of, quite a bit of research involved, and we have been working, we are basically, working with some of the acclaimed researchers in, Colorado University, Boulder, and they have like immense background on astrodynamics and bioastronautics, and phenomenal work there. So with the increased interest in the space from both like the civil, national security, and commercial reasons, plus all that increased activity, we have a problem that lies in front of, which is a space debris problem, which a lot of us here cannot relate to. We see the trash, that's a problem here in a different way, but there's a similar problem that is happening in the space, But the challenge here is all those debris are flying at such a speed, it's almost like a bullet traveling, right? So, and it could be really damaging to any astronaut or any assets that go into the space. And the challenge is there's a lot of work beginning to happen to kind of how do you kind of remove that problem, the space debris problem. So there's SpaceWorks, which was Space Force equivalent, similar to like AFWorks. They came out of a solid station around orbital prime. So it was around like, technologies that can really help in that on-orbit service, assembly, and repair. The whole idea is, can we create something more sustainable and reducing this debris problem there? So in that, I mean, all that till now, like, why VR here? What does the VR has to do here, right? So the unique thing here is, like, whether it's an active debris removal or any of that. So a lot of this, what action which needs to be created is in very uncertain territories, right? You have environmental factors change, which we don't have a control there. The bandwidth that is required, that kind of changes. All that uncertainty that is involved. And all that sensor data that comes in from a human perspective, it is almost impossible to kind of take decisions quickly what needs to be done. So what VR does in this scenario is you can really create all this uncertainty and simulate that in a VR environment, where the operator who's ultimately going to control the spacecrafts are going to be kind of trained by creating this uncertainty and all that, which will basically enable them to kind of improve, their decision making or the situational awareness to make the right decisions when those events really happen. So it's all about using VR to effectively train the spacecraft operators, and then be able to create that environment and uncertainty which will allow them to take the right decisions. As with anything, you get better at something if you repeat it. There's nothing, no replacement to repetition, right? That's practice, whatever we call it, right? And that's exactly what you're trying to do here using VR, but in a space environment. And we believe, considering that humans are not going to be flying in the space trying to fix it, it's going to be one of the critical infrastructure that is required to actually accomplish the task that we are kind of thinking about, right? So that's where the VR comes in. So this is the phase one. We are still kind of talking to multiple end users and Space Force. We have seen some interest there, but we are basically working with them in terms of creating the feasibility and who is going to work there. So we already have a demonstrable, basic demonstration with CU Boulder, and that's something that we are kind of utilizing it to talk to the different end user and see, like, is there somebody who can really looking to utilize it in the short term? But in the long term, we believe that's going to be a critical layer that is required.
Are you planning on doing like a AI or a randomizer where you can kind of have an infinite amount of variables, like if they make this classic choose your adventure books, like, hey, they made this decision, they're going to do that, or is it going to be very scripted?
No, I think ultimately that's the goal. So there is obviously a simulation engine where there is going to be different variables. You're going to identify variables like you have the solar rotation, the radiation pressure, all those things, whatever vary in the space, you can really vary. And based on that, the spacecraft, like in terms of their approach to the certain object they're looking to remove, or even in terms of docking, like you're taking a position there. So you can take the right decision what needs to be done, right? So yes. Yeah. So on the simulation side, we are leaning on the expertise that the CU Boulder brings in the astrodynamics. That's the astrodynamics part of it. And then we have a bio. So how this VR is to be effectively used for training, that's the astronautic part of it, like in space, how humans behave and all those that's again the CU Boulder piece. We bring in the capability from the VR point of view, like we can create high fidelity physics simulations, which otherwise is not possible without the cloud environment. We can bring in like multiple users, like whether you talk up 2, 3, or hundreds, to kind of collaborate in that same environment and be able to seamlessly change different scenes and position to see it from a different point of view and all those things. So we're going to bring all that, and obviously the 3D AI will come in at some point, not right now, but where you can do the accurate overlays of any virtual object on any physical assets at a millimeter precision. So all of that is what we are going to bring in. But we are not like space specialists. We leave it to the experts there. Yeah.
Well, see, I heard Nat Bender, I don't know if you noticed this, but talking about trying to fly, these spacecraft into position and stuff. Don't let those Space Force guys try to fly. You have them give us a call, and we can fly pretty much anything. Yeah.
Awesome.
Oh man, well, that's wild.
My issue is you skipped. Well, you did, but like maintenance is awesome, like space awesome. But Vader and we want you to help us find things to kill more accurately. So we got to figure out how to bring that in here. So it'd be awesome if you could take a Oculus headset from space, look down, at the area of interest, and then quickly pass me some, millimeter precise coordinates would be great.
I think that's also. I definitely think that's in the works. Yeah,
I'm sure that's being done.
Yeah. I mean, there's a lot of scope here. Yeah, we are taking baby steps. I mean, this technology is just kind of beginning to come up, right? So. What's possible, and most of the use cases today you are seeing is the use cases things been done in 2D and people trying to reflect in 3D, but you'll begin to see use cases which is only kind of conceivable in 3D. So that's going to happen. That slowly, things, all this kind of comes together. All those things are going to happen. And yep.
So, so an object that's not moving. So to get it down to the millimeter precision. Overlays. So virtual overlays on an airplane, like you're talking about when we're talking about the Osprey. How hard would virtual overlays on something that's moving? So, like I have an F-35 wingman out there. I mean, you could theoretically put all sorts of like virtual overlays or whatever. However you're going to do it. How hard? I mean, is that just like leaps and bounds, more difficult?
No, the thing is, we can actually, in an aircraft, we can, if you tell us, track this parts, we can actually, even the aircraft is moving, we can track it. The only thing is, we haven't tested that, at what speed those accuracy breaks and all, right? So, but in a normal kind of like in a logistics center where things kind of move and you're tracking different parts as they move, even in the robotic arm case, if you are kind of looking at different parts where you want to track for certain reasons, we can really track that. But the speed at which the F-16 and others will operate, I think that's it will be a function of, it's not only us, it will be a function of even the sensors which is on the device, which we are basically leaning on to do quite a bit of thing. It's not something that's our expertise, right? And those sensors capabilities will keep on kind of improving, and you will have a day where you can do that to same millimeter precision. For us, if the sensor data can support us, we can do it.
That's pretty wild. That's
cool. Would you say that's normally a limitation? Like when you're saying, hey, if you can get me this data, I can make this happen, and they're like, we can't get you that data, or sensors pretty good now?
The sensors are for largely most of the use cases, sensors are pretty good. For example, like, there are use cases where you need to kind of drill a hole at, one, almost like 1/100th of a millimeter. I mean, those kind of precision, you can't do it today, because those are the things which we don't have that kind of precision today, right? So there'll be a day when those precision happen, even those use cases will open up. It's more around like today, with even all the constraints that are there with the sensors, the optical pieces, and even like the headset being bulky or being $3,000, but there are use cases, the value that you get for that $3,000, if I can save like $100,000 by using a $3,000, it just makes a case for it, right?
Yeah.
So as the kind of basically the technology kind of keeps on improving, you'll make even the use cases which has high volume but not necessarily can work out with the price points that are today, or even the use cases which requires technical accuracy or some of that which is dependent, which may not be feasible today, but there are so many. It may be like 20% of the use case, but there is 80% of them you just can make things better, faster, or cheaper, like everything you can do.
Mm-hmm.
Is there a use case in using like the LiDAR and then the kind of the computer optics to assess stress on platforms and things? So to be able to look at maybe mechanical arms or things that are load bearing and say like that is a point that is experiencing abnormal amounts of stress and may fail.
No, I so far as I know, there are companies which are working on that.
Okay.
Actually, it's all about like it's just a function. As long as you have sensor which can kind of capture that, like that detail, you can always then use an AR can come to kind of show you, like you wear it and you just walk through it, and it'll show if there is let's suppose there is a pressure gauge and it's kind of in a pressure limit, which is if either you have to go to a laptop to see, it has exceeded something. You walk through and that is reflected right in front of you, and it will show you, it will turn red because it already knows the rule that if beyond this the pressure is way too high, it should be red or yellow, or all of that could be visually done. And that's what I was talking about. The same thing, you're doing it visually, kind of improves, things, makes things so much more faster and, more efficient, right? So, I know companies that are working on that, like simulating those things and then using AR to kind of walk through that, but that's not our expertise. It doesn't really necessarily use our core IPs, but we can help if somebody's looking for.
What is kind of your longer term? So obviously you have your robotic side and you have your Space Force side. Aside from those, do you have kind of a longer term perspective or goal that you guys are trying to move towards at Grid Raster?
So for us, like we have always been kind of seen, this augmented reality and virtual reality to overall go mainstream. Not only aerospace, defense, and automotive happens to be where the maximum value is seen today, but we see a lot of value even in medical simulations, right? In education, it's phenomenal. As you like the way you're training yourself, or the pilots in VR could be huge. Same thing you can take it to any STEM classes, right? Even to the universities and all. And there are companies we are kind of working on that part as well. We bring the capability more from an infrastructure angle, right? Like if you have something that is working on a headset, now you want to kind of take that use case to hundreds and thousands and millions of users across different locations, and you want the performance, the accuracy, and the scalability, we can come in and make that happen for you, right? So our larger goal is, there is going to be a metaverse more from an industrial angle, even from education and all of that. So we hope to kind of power that using our infrastructure so that everybody can go mainstream, and some of the performance and the precision and the scalability aspects we can take care for them, so that not everybody has to do and struggle with those aspects.
Nice. Well, Bender, any parting shots before I let Dijam go?
Well, I was going to ask actually how you, kind of your background, how you got, I know we talked a little bit about how you got started, but you and your partner, like how did you guys meet and decide that this was what you were going to, like you said, right? You put away a different career and you're like, here we go.
Yeah.
How did that happen?
Yeah, no, at least like all the founders, we know each other for the last 24 years. So we did our undergrads together. People went in different directions. Some continued in the PhD and all. But the one thing that has been common across all three of us has been we have been part of this whole the network, the mobile devices evolution. So I worked on the first mobile device with the dual core processors, which was done by Texas Instruments. So long back, right? So, but we have been part of this evolution that has happened on the device part of it, on the infrastructure part of it, and even on the cloud part of it. So over a time period, it's all about what are you enabling? Are you enabling the voice? Are you enabling the video? Are you enabling, voice over IP with this? And then it so happened in 2012 when we started working on 5G. One of the key requirements of the 5G was one of the key use cases of the 5G was, augmented reality and virtual reality, because it required low latency, humongous amount of data. Then you are trying to move the compute closer to where the data is getting generated, right? That's where we initially started working for kind of how that would be possible in all the things that are coming together. So those insights, basically, we pretty much kind of utilized to kind of start the company, because we saw that there's never going to be a time when the devices would become so powerful that they can actually run immersive applications, right? Yeah, because the form factor is small. You are trying to cram in more and more compute, but the demand is like 100x more. It's never going to happen. So where would that compute come from? And that's where the cloud was the answer. But the problem was, what about the latency? And we had those insights that, what is happening? The cloud that we think of today, which is centralized, it's not how the cloud is going to be in the future. The cloud is going to be more like a hierarchy of compute. You have compute sitting on your house, base station of your telecom network, and then you have the co-location centers, then you have the centralized cloud that we see today. So we have, those insights into how things are going to evolve, which basically where we kind of venture into kind of starting the company, and kind of with our core expertise around that, we're starting breaking down some of those key technical challenges.
That's pretty wild stuff.
Yeah.
Well beyond my.
Well, it was a good insight, because you're exactly right. It's easier to build a super fast network that everybody's going to lean on, rather than somehow cram in all this computing power into a product that objectively everyone wants as small as humanly possible. So nobody's looking for the biggest VR goggles. You know what I mean? So,
the interesting thing, that's a firm belief that we have. I think it may be 5 years, maybe a decade from here, nobody will talk about where the compute is coming from. It will almost become ambient. You won't even talk about that. It will be there everywhere. It's all about what application you want to run, experiences you want to learn. So that's where we will ultimately land.
Yeah. One kind of the caveman side of that is, there were so many times when cell phones were relatively new, is you wouldn't have cell phone coverage, and you'd have data gaps and all that. And now you go on a hike, or you're in the middle of the mountains, and you're like, oh, I have LTE, I've 5G still. And you're like, man, how is this even possible? But in the future, it's just going to be intrinsic. It's just a part of life. It's just going to be there. Well, awesome. Well, Dijam, anything to let us know? Anything we missed before we end the recording?
No, it's an absolute pleasure talking to you both. Thanks again for the opportunity. Hopefully, some of the things we are doing may be of interest to. We are happy to kind of share more experiences. But thanks a lot. Yeah,
awesome. Well, and how can people reach out or learn more about the company?
Well, they can reach out to me Dijam, my first name, @Grid Raster, the company name.com. So, or they can go to our website, and just kind of, there's a contact form. If anybody kind of reaches out there, we'll absolutely kind of follow up with the conversation.
Okay, well, awesome. Well, I'll put both the website and your email in the show notes. And then if anybody wants to reach out to us, info@kodiakshack.com, and then kodiakshack.com is our website. Remember to like and share and subscribe and do all the things that the social media stuff lets you do. And thank you again, Dijam, for being on the show, and Bender for killing it with them questions.
No, thanks a lot. No, pleasure talking to you both. You all have a wonderful day ahead.
Thank
Yeah,
John.
you too. All right,
Yeah,
see ya.
thanks for having me.